Good afternoon everyone. Today we will have a lecture on double angle fillet welded connections. So in previous lectures we have seen the welded connections, that is the fillet welded connections. Already we have discussed in previous lectures. Those who have not gone through the previous lectures, because previous lecture was very important, in which we have discussed the various concerns regarding how to find out the length of welded connections. So I have actually solved the problem related with the welded connections. uh, so I have solved the actual numerical I have solved on paper, so that the concept is clear. Okay. So how to find out the loads, or how to transfer the loads, or what is the factored load, how this factored load to be transferred on the ends of the angle sections. So all that concepts, it has been cleared in the previous, that is the numerical which I have solved. Okay. Based on the previous numerical, today we will solve the same, that is we will find out the length of the welded connections. In today's lecture we will find out the length of welded connections, but for double angle sections. In previous problem we have solved the we have calculated the length for single angle, but here in this today's problem, we will solve, or we will find out the length of fillet weld for double angle sections. Okay. So today's problem was, it is very that is important, but it is based on the previous numerical. It is based on the previous lecture which I have already uploaded on that is the YouTube channel. So you have to refer that previous lecture, so that this lecture you can understand very well. Okay. So I am going through, or I am reading the problem related with the double angle welded connections. So here there is a problem for double angle welded connections. Which things are given, and what are the different things to be calculated. Here important is the length of fillet weld connections. How to find out the length is important. Okay. So a tie members, that is a tension member. A tie is nothing but a tension members. Some part is little bit, it is blur. So a tie member in a roof truss consists of two ISA, that is Indian Standard Angle. So how many numbers of Indian Standard Angles are there? There are two numbers of Indian Standard Angles. Okay. So two ISA having size 125, that is 125 by 75 by 10 That means this 125 it represents L1 side of the angle sections. 75 is the L2 side, and 10 is the thickness. That means L1 by L2 by T. L1 by L2 by T. That means this is unequal angle section. Okay. So it is very important that in this case, which part of that angle section will be connected with the gusset plate. I am repeating, whether this 125 length of this angle section will be connected to the gusset plate, or whether this 75 length will be connected to the gusset plate. Okay. So there it is unequal angle sections. Okay. So we have to connect such leg which will give, or which will take, or which will have the maximum strength. Okay. Which will give the maximum strength, or which will have the maximum strength. So such part will be connected with the gusset plate. So what the logical says, whether 75 will be connected to the gusset plate or 125 will be connected to the gusset plate. So we will connect 125. Why? Because larger length will be more safer, or it will have more efficient, or it will carry more strength, or it will carry more load when we are connecting this 125. Okay. So 125 by 75 by 10, and this 125 will be connected with the gusset plate instead of 75. Okay. Connected on either sides of gusset plate. This word is again important. On either side of gusset plate. What it means? That means gusset plate, it is at center. On either side, on right side there will be an angle section, and left side there will be an angle section. So this angle sections, it has been connected on either side. Either side word is important. Okay. So connected on either side of gusset plate, having 12 thickness. What is the size of gusset plate? This gusset plate is having a size of 12 What is the thickness of gusset plate? It is having 12 What about the thickness of angle section? It is 10 These are the two thicknesses. This is also 10 and this is also 10 Okay. This is also 10 but this size is 12 mm. Okay, this size is 12 mm. This size of gusset plate is 12 mm. Okay. Either side of gusset plate having 12 mm thickness, it is subjected to factor load of, yes, what is the factor load given? It is given as 480 kilonewtons. So this 480 kilonewton will be taken by these two angles which are connected back to a gusset plate, which are connected on either side of gusset plate. Okay, every word in this question is important. Okay, so these two angles are connected on either side of gusset plate and it is carrying a load of 480 kilonewtons. Okay, so assume the connection is to be made in a field. Again, a word is important. The connections are to be welded in a field. What this indicates? So we have to refer the table for partial safety factor. In that case, there were two: shop weld and field weld. So we are using field welding instead of shop welding. We are using field welding. तो फील्ड वेल्डिंग के लिए कितना रहेगा? द gamma mw, the gamma mw for field weld will be 1.5. It will be 1.5. तो शॉप वेल्डिंग के लिए कितना रहता है? 1.25. बट हियर इट इज gamma mw, that is partial safety factor for field weld, will be 1.5. It will be 1.5. Every sentence in this question is important. Again, UFU, that is the design, that is the ultimate design tensile stress. It has been given as 410 Newton per mm square, okay. The FU is given. If it is not given, then we can directly take, or we can assume 410. It is always the constant value of 410. It will be given in the question, or if it is not given, then we can directly use as 410 Newton per mm square. And CXX, what is the CG distance from base? CG distance from base, so it is 42.4 mm from base. Okay, so this is nothing but the Indian standard angle. So by the given data we will draw a figure. So there is a gusset plate at the center. This is nothing but the gusset plate which is kept at center. On either side of this gusset plate we are connecting this angle section having a size of 125 by 75 by 10 mm on right side and on left side. Okay, what about the CG distance where the load it is supposed to be accumulated? It is the CG distance is given as 42.4. The distance of CG, it has been given as 42.4. So after subtracting this 42.4 with the actual distance, that is 125. So I am subtracting this 125 with 42.4. So it comes to be 82.6. The distance from this point to, the distance from this point to this point is 82.6. So this is 82.6. How we have calculated 82.6? So this total distance is 125 because we are connecting with 125 length instead of 75. We are connecting L1 leg to the gusset plate in order to achieve the maximum strength. Okay, so therefore 125 is the total length from this point to the base to the toe. So 125 minus 42.4, it comes to be 82.6. Okay, so this distance is 82.6 and the remaining distance is 44.4, 42.4, which will be used for the further, that is while we are taking the moment at CG, So here the plan is there, and here we have drawn the sections. So here there is an angle sections. Okay, this is nothing but this with a inclined surface, it is nothing but the gusset plate, and this rectangular part is nothing but the angle sections. Here is the load taken. Here why we have divided this 480 by 2, because this load it has been taken by this two angle. The combined load will be taken. Okay. So what is the load taken on single angle? Because we will find out the length of that is the fillet weld on single angle. Okay. We are calculating for single angle, that means the same length will be repeated for other side also. Okay, first we will find out for single angle. So therefore 480 divided by 2, that means the load taken by single angle is 240 kilonewtons. Okay, then this 240 will be taken by, this 240 will be transferred, sorry, this 240 will be actually at the CG, at this line. It is wrongly mentioned here, so it is actually at this side. Okay, this, it will be in this directions. Okay, so this 240 will be right side, it will be balanced by 240 left side, so this will be in this way. Okay. So this 240 will be balanced by these two forces, which is F1 force and F2 force. So this is F1 at the bottom, F2 at the top. Okay. So these are two forces, F1 at the bottom, F2 at the top. What is the distance of F2 force from CG? 82.6. What is the distance of F1 force from CG? 42.4. Okay. So we will rotate this F1 about CG, F2 about CG. Okay. So this concept was very much I have cleared in previous lectures. We have drawn on paper, we have drawn this section, how this, it has been transferred, right side will be transferred to left side again will be balanced by the two forces F1 and F2. How this PS, that is the design strength of fillet weld per mm, design strength of fillet weld per mm multiplied by length, because what is force? Stress into length. Stress into length is the force. Stress into length is the force, because what is the definition of stress? So stress is equals to, gamma is equals to load per unit area, P divided by A, load per unit area. So what is load? Load is equals to stress into area. Stress into area, area is nothing but length into T. So already we have calculated, multiplied with PS into T. So therefore remaining is L2. So stress is equals to, load is equals to stress into area. This is a cross multiplication. This concept I am repeating, this concept I have cleared in previous lectures. Okay. Next I am switching over the things which has not been given and we will assume. So in previous problem the size of fillet weld was given, but in this case, in this problem, size of fillet weld is not given. So we will assume the size of fillet weld. Okay, we will assume the size of fillet weld. So how to assume the size of fillet weld? Again we have to refer IS 800 2007, the page numbers. Okay. So that page numbers is nothing but this 78 page number of IS 800 2007. I am repeating, we have to refer the page number 78 from IS, that is 800 2007. So what this 2007 IS code indicates or says, the minimum size of first run or of a single run fillet weld. What is the minimum size of fillet weld? So minimum size of fillet weld is 3 mm when we are having the size of I sections, or sorry, size of angle section up to and including 10, when the thickness is 10, because we are having the sizes 125 by 75 by 10, so 10 is the thickness. So up to thickness 10, with how much is the minimum size of fillet weld? We will take as 3 mm. So we have taken this as 3 mm. The size of fillet weld minimum we have taken as minimum we have taken as 3 mm from IS 800 2007, and the table is 21. Table is 21 from page number 78. So we have taken this from page number 78. So we have taken this from page number 78. Okay. So this S minimum is 3 mm. What about the maximum? Again maximum clause, it has been given in IS 800 2007. So I am scoring, I am taking this the bottom of the page. Yes, it has been given, yes. So 10.5.8.2, 10.5.8.2 of page number 79. Yes, 79. 10.5.8.2, that is page number 79. So this clause is important for maximum, that is this clause is important for the maximum size of fillet weld. So what this clause says, so where the fillet weld is applied to the rounded toe of a roll section, the specified size of weld should generally not exceed. It should not exceed 3/4 of thickness. It should not exceed 3/4 of the section at the toe. That means section at the toe, that is the thickness. See figure 17b. See figure 17b. So we have to refer the 17b figures. Okay? Yes, this. So this, it should not exceed 3/4 of T. This is 17T. That means this angle section, when it is connected to a gusset plate, so uh, some space to be left. Okay. So this is the fillet weld, and this top some surface is kept empty, left in the sense empty. So it should not exceed 3/4 of T. It should not exceed 3/4 of T. 3/4 of T, which has been mentioned in clause, that is 10.5.8.2. So it has been mentioned in this clause 10.5.8.2 that it should not exceed this. Okay? So it should not exceed 3/4 of thickness of this. Again I am switching over to the notes. So 3/4 of T. So T in this case is, T for this section is 10 mm. What is the thickness for this section is 10 mm. So 3/4 of 10 is 7.5. The minimum is 3, maximum is 7.5. So we will take intermediate of 6 mm. What is the size of fillet weld we have assumed? The size of fillet weld which we have assumed as 6 mm. Okay. So from 3 to 75 intermediate we have assumed as 6 mm. We have assumed as 6 mm. Again, design stress in weld, we have to refer again the IS 800 2007 from page number 79. Okay. So design stress in weld FWD, it is equals to FU, FW or FU divided by square root of 3 gamma MW. So 410 is the value which has been given in the questions, divided by square root of 3, and 1.5 we have taken this for field welding. At the starting problem I have shown you, it has been given in the question that you have to use field welding. So field welding, you have to refer the table. From table we have to take this 1.5 for field. For shop we will take as 1.25. For field we are taking as 1.5. So 410 divided by square root of 3 and divided by 1.5, it comes to be 157.81 Newton per mm square. This we have taken from page number 79. This formula we have taken from page number 79. Okay. So refer page number 79 from IS code. So you have to refer the page number 79 from IS code. Again, how to find out the strength of weld per mm, because I have shown the figures. So PS into L1 and PS into L2. What was the force F1? The F1 value, how to find out F1? The F1 was, F1 is equals to PS into L1, and F2 is equals to PS into L2. Okay. So for this PS to be calculated, the strength of fillet weld per mm. So how to calculate this? So PS is equals to 0.707 S into FWD. FWD, just now we have calculated FWD, so 0.707 into S we have assumed as 6, 157.81, simple multiplication is there. The answers comes to be 669.14 Newton per mm. Okay, because it is per mm. Length of weld. So how to find out length of weld? So it is LW is the total length of weld. Okay. So P is equals to, just it has been multiplied with LW. So P is equals to the whole formula into LW. What is the load taken by the fillet weld? It was originally 480, but it has been divided for single angle. So 240 is the load taken by the single angle. So 240 into 10 to the power 3 is equals to 0.707 S into FWD. The same formula up to this, and only is the extra is length. Okay. So length of fillet weld after simple divisions, it comes to be 358. So this 358 is the addition of this L1 and L2. It is the addition of L1 and L2. So L1 and L2. So separately we have to find out L1 and L2. So how to find out L1 and L2? So if this is nothing but the simple case, simple figure is there. This is angle sections in which this is the load which was given P, and it has been balanced. This is load P, it has been balanced here, but for this balancing there are the two forces. This was the F2 force and this was F1 force. We have to take the about CG. We have to take the moment about CG. So moment about this F1 about CG, F2 about CG, and P about C. But P is along the same line, so P will be 0. So this moment we are taking here. The moment of all forces about Cxx or Cg is equals to 0. The applying conditions of equilibrium, summation of all moment of all forces about Cg, that is equals to 0. That is at the point where the load it has been taken care. So Ps is the load, Ps into 0 plus what are the different forces? F1 to be rotated about the Cg and F2 to be taken moment about the Cg. So F1 is anti-clockwise, F1 is anti-clockwise, so anti-clockwise, F1 is anti-clockwise, so minus F1 into what is the distance of Cxx, it has been given as 42.4, so F1 into 42.4, it is minus, why? Because anti-clockwise. F2 about Cg is clockwise, so F2 into 82.6, how it has been calculated, so 125 minus 42.4, I have shown you in the previous page, so 82.6. So this part is 0, so taking towards right, so what is the relationship? F1 and F2, but what is actually F2? F2 is nothing but Ps into L2, and what is F1? F1 is equals to Ps into L1. Okay, so Ps and Ps get cancelled, so L1 and L2 relation it comes to be 1.95. So L1 is equals to 1.95 times L2. L1 is equals to 1.95 times L2. So put this value of that is L1 in this equations. Put this value of L1 in this equations. So what is the value of L1 and L2? So first we will calculate the value of L2. The L2 value, L1 plus L2, the L2 value it comes to be 121.60 or approximately as 130. Okay. Again 130 to be kept in this additions. So after subtracting, the next is 236.90. So again we can assume as 240. That means the length of L1 it is 240 and the length of L2 it is 130 mm. So in this way we have calculated L1 and L2 by considering the double angle sections. We have solved the numerical related with the double angles. Okay. So in previous lectures we have seen single angle, but in today's case, today's lectures we have seen the double angle sections. Again there is this figure, a small figure it has been drawn. So 240 was the bottom length, so 240 is the bottom length, 130 is the top length. That means at the bottom there is more welding will be required, more length of weld will be required, whereas at top a little bit less welding is required. Okay, so this distance is L2 and this distance is L1. So L1 we require more as compared to L2. So this L1 the length of L1 is 240 and the length of L2 is 130 mm. Again next case we are finding out the different length. We have to solve the numericals related with again double angle, but in double angle sections we are finding out back to back. Here it is along the same side. Okay, so again I am solving the problem related with the double angle, but here in this case it has been applied on same side of the gusset plate. It is to be taken care along the same side of the gusset plate. Okay, so solve same previous numerical, that means the load was 480 same, but here in this double angle we are taking or we are connecting this double angle on the same side of gusset plate, it was in previous problem on either side of gusset plate it has been applied, but in this case, in present case, it has been connected on the same side of gusset plate. Okay, so here it has been applied or it has been connected on the same side. So along which side we are connecting? So we are connecting this we are assuming as L1 we are assuming L1 is this side, and L2 we are connecting this. That means L2 is the side, L1, L2 and T. So L2 is this side. This side is nothing but the L2. Okay. What is the length for L2? It has been given as 1, that is 75. So this distance we are considering this as 75. So this distance we are considering this as 75. Okay. Again for the same case we will find out first the length L1 and L2. First this load will be transferred, but in this case again the size of weld will be taken as S minimum we are taking as 3 mm from that is IS 800 2007. S max again the maximum is 3/4 of 10, it comes to be 7.5. So S for intermediate of this is 6 mm. Again design stress in weld, so we have to find out the design stress the same way. 157.87 is the value, same. Strength of weld per mm, the same value will be taken as 669.43. What about the load? Yes, this load concerned is important. In back to back we have divided this 480 divided by 2, but when it is along the same side, when it has been connected on the same side, that means this is nothing but the gusset plate and this is nothing but the angle section which has been connected on same side. Okay, it has been connected on same side, so that means the load taken on this angle sections, the load taken by this angle sections on the same side, that is 480. We will not divide it by 2. Okay, we will not divide it by 2 for when it is on either sides. When it is on either sides, at that time we have divided this by 2, but on same side of gusset plate this will be 480, but here in this case we have taken as 240, but here we will take as 480. So little bit difference is there. So 480 multiplied by 10 to the power 3, again the values for this is 717.02 mm. So this 717.02 mm will be taken by the two length L1 and L2. Okay, again we have to take this moment about the center, about the CG. So taking moment about the CG, so we have to take this this CXX distance will not be considered here. Why this CXX distance will not be considered? Because CXX distance it was for L1. Okay, but here we are connecting with L2. Here this L2 we are connecting with L2. Okay, so this CXX distance will not be used, and we will directly take the moment of F1 and F2 at the center. That means the distance is 75 and 75. The distance will be same as 75 and 75. Okay, the distance will be same 75 and 75. So here the distances will be same. So PS is equals to the formula which we have taken, the moment about the CG we have to take. So after all calculations, find out the value of that is L1 and L2. So remaining part you have to solve, or you should solve the remaining problem. Only thing the distances is same 75. The distance for F1 about the CG is 75. The distance of F2 about the CG is 75. In previous case is we have subtracted from 125, but here there is no use of CXX. There is no use of CXX. I am repeating, there is no use of CXX. Just we have to multiply F1 and F2 by 75. So after multiplications, find out L1 and L2, and from this total 717.02 subtract this L1 and L2, so that the remaining L1 and L2 distances to be calculated. Here one thing to be kept in mind, L1 and L2 will be same. L1 and L2 distances length will be same. Why? See the figure. This, it has been connected at the sloping side. This is also connected at the sloping side. That means this gusset plate is straight, here also straight. This is connected with sloping side, this is also connected with sloping side. That means L1 and L2 length will be same. L1 and L2 length will be same. Okay, that means this distances and this distance will be same, L1 and L2. In previous case L1 was a little bit more as compared to L2. Why? Because connection was different. Okay, here it has been connected along the sloping side. Okay, curve. Okay, therefore L1 and L2, this L1 and L2 will be same. This L1 and L2 will be same. So you can calculate these values. Here we will end this today's lectures. So in next lecture we will start somewhat different topic. Therefore I have covered this topic today. So in next lecture we will cover some different topic related with the steel structure. Here we will end this today's lectures. If anyone having doubts or queries, so they can ask me. Okay, so thank you everyone. Thank you.